And today we're going to do a video again, but this time again with my sister. Hi. So actually, if you're, what are you thinking that this presentation is made by my sister? No, but
it's made by my sister.
Yeah, exactly. So it's made by me, but she's gonna join us today. So today's presentation and today's video is totally related to motion and
Measurement.
so let's go into the video.
So guys, here's a presentation my sister made about this motions and measurement.
So let's go. Motions and measurement by Tushara. But we're gonna have my sister here.
Yeah. Am I?
So guys, if you don't know my sister's name, it's Ritvi. Say hi.
Hi.
Again. Okay, so let's go. Let's just go with.
I don't know if it's again and again, the same thing.
But let's just go with the presentation. Ooh, the curtain's lit up. Okay, let's go. So guys, today this presentation is extra big. It's so big. It's not as big as our food presentation, which was super long. Like the presentation is 32 minutes. The video.
It's like the longest call with my sister tried.
That is a 46 questions.
Like the method is getting everything same. What is this? They're like giving continuously the same question. And I was really irritated too. You know, hear that question again and again and again.
But
Saying it 100 times.
But let's go with the presentation because we have to move on this track. So guys, learning outcome of today's video is first we're gonna learn measurement. I'm sorry if the letters are too small, but I'm gonna read them out. Only for the learning outcome and few of them it's like too small because there's a lot of place occupied by them. So let's go. First is measurement. Then we're gonna learn conversion. Oh my gosh, that's pretty like slow, but still. Next, standard and non-standard measures. Next, we're gonna learn measurement of a scale with broken ends. Oh my god. Okay. Next, we're gonna learn least count. Measuring the length of a curved line.
Can I say this?
Okay.
Motion.
Motion. Rest.
Oh, yeah,
Rectilinear motion. Circular motion. Rotational motion. Periodic motion. Oh my gosh. Combination of motions. The last one is SI units. So guys, let's go. Yes. So actually in the before video when I did with my sister, the whole presentation, everything I was only like reading. But this time I'll give her a chance to read. She can read the titles and I can read the points.
Oh, yeah.
Okay, so let's go.
Oh, the current is measurement.
In the classification definition, which is standard throughout the physical sciences, measurement is the determination or estimation of ratios of quantities. Quantity and measurement are mutatively defined. Quantitative attributes are those possible to measure, at least in principle. If you didn't understand whatever I said, I'm gonna just say the simple one. And a simple definition of measurement is, it's like comparing the you can say the comparison of an unknown quantity to a known quantity. This is exactly what you can write for measurement. Now, measurement can be taken by various devices such as scales, which is the most common measurement thing that we all have in our geometry boxes, circum boxes, whatever.
What do you call it?
Do you have a scale?
Oh, yeah. Mine is a Barbie scale, and that's my favorite.
Yes, so we all do have these scales from which we measure.
So here's a picture.
Yes, there's a picture right there, but that's actually not a scale. That is a measuring tape. Do you know what's a measuring tape?
Oh yeah, I know that brand.
No, it's like when you go to a tailor shop. Guys,
Yeah,
for whoever who don't know what. Yeah, which you check the sizes of how much is your chest. No, not you, but chest, stomach, shoulders.
Yeah, the checks like that. That's all.
Yes. So measurement. So guys, the next we are going. So this is first. What is measurement? Now let's go with the second one. Next.
Conversions.
Now conversions. First of all, meter is a standard unit of length. The symbol of meter is m. Yeah. Now each meter m is divided into 100 equal divisions, which are called centimeters, which is also known as cm. Now, okay, each centimeter has 10 equal divisions called millimeter. Thus, 1 meter equal to 100 centimeters. So now actually I will show you one thing. This is all what we have. If you don't know, I'm going to keep it a little bit closer. It's a scale. Obviously, you have it in everyone have it in their geometry boxes. So now here we have these points such as 0, 1, 2, 3, 4, and all. So now,
I don't care if I'm not able to see them.
why do you don't care? You have to care. So we have all these, like you can see, but you cannot see clearly, but still, you have points such as 7, 8, 9, and all.
12.
Yes. Now these centimeters, these are 9, 10, whatever you see in your scale, 15 centimeter scale or 30 centimeter scale. Now, what am I saying? Centimeter. These are the centimeters, such as you have here 0, 1, 2, 3, 4 in a small scale. Any scale till 30 centimeter or what? I'm not asking about a measuring tape, but a scale. So here you have centimeters and all. Now these centimeters are 100 centimeters equal to 1 meter. Now these centimeters have 10 equal divisions. You can see between each centimeter, like centimeter 10 to centimeter 11. In middle you have 10 lines, 10 small lines, which are called as millimeters. These are the 10 equal divisions, and these equal divisions are called as no, the 10 equal divisions, not 100 equal divisions. But if it's 100 equal divisions, then centimeter. If it's 10 equal divisions, millimeter. Yeah. So guys, 1 meter equal to 100 centimeter. 1 centimeter equal to 10 millimeter. Now for measuring large distances, meter is not a convenient unit. So we define a larger unit of length, which is called a kilometer, which is known as. Now 1 kilometer equal to 1,000 meters. Now simple multiples of units that are used for measurement of larger distances are the multiples of SI unit. For example, deca, hecto, kilo are actually, they are present in front of the meter to make it like a larger amount, like 1 decameter equal to 10 meters. Then 1 hectameter equal to 100 meters, and now 1 kilometer equal to, we all know, 1,000 meters. Now the thing here is, we even have, actually I didn't show them, but they are also simple multiples of, not multiples of units, but they are some simple units, which are the units that are used for measurement of smaller distances, and those are centi, milli. So those are present in front of meter, and those are lesser than a meter, and they are used to measure of smaller distances.
Oh yeah.
Now let's go with the second one. Third one.
Standard and
Now, non-standard measures. Now, these non-standard measures are the lengths of steps, arms, hands, or fingers of different people are different because each of us cannot have the same. Because now look at her hand, look at my hand. Look, give a closer look. Hers is a smaller and mine is a little bit bigger. Now, if I measure my table with my hand span, it'll be different. It'll be like the amount from hers, it'll be smaller because I can take bigger steps, but she'll take smaller steps. So now here the units are different from person to person. I can be different from my mother. My mother can be different from her aunt. Her aunt can be different from her friend. Each of us can have different thing. Okay, there are people who have a little bit same, but not all people. So that's why the hand spans or the lengths of steps, arms, hands, fingers of different people are different. Therefore, the distance measured with their help is not always reliable or accurate. Now, these methods are therefore called non-standard measures because they don't have a standard unit or standard measurement. Because when I measure my pouch, it will be different. And when she measures my pouch, it is completely different. Now, I will measure it. I have one. I got like a 1.5. But when you measure, do you even know how to measure? You have to keep it like this. You have to keep it. Or that's fine. Let's go with hands. See, hands, 1. My whole hand is enough for this. But for her, 1, and here 2. So for her 2 hands, for me 1 hand. Now this is, so that's why this pouch doesn't have a standard measure. Now such type of the lengths of steps, arms, hands, or fingers of different people are different. Due to that, the measures with these type of things are called as non-standard measures. I mean, you're not actually the age to understand this. You're 2nd grade. Okay. Okay, guys. Now we're going to learn about standard measures. Now, standard measures that are the same all over the world are known as standard measures. Now in October 1960, the 12th General Conference on Weight and Measures adopted the International System of Units, which is the system. International units is a set of units to maintain uniformity all over the world. Now, why do we need standard measures? Because now, if I take this, now scale is a standard measure. Now, whatever 15 centimeter scale you take or 30 centimeter scale you take, my scale and their scale will be the same. So that's why when I measure my pouch or whatever with this, I get an accurate unit. Whoever measures it with different scales also, with different units, not units, devices with the same units also, you can get it. Or you can just, if you do it with different units, you can convert it and give it. Now, these measures are important for us. That's why standard measures are there. Now, what happened in October 1960? The 12th General Conference on Weight and Measures adopted the International System of Units, where so the whole world will be using the all over the world measures that are same all over the world are known as standard measures. Now, all over the world is using the standard measure system. There are still people who use non-standard measures. Even in our areas in Hyderabad or wherever, you can see your mom or someone asking, can you give me an arm length of flower garland or still? But mostly we use standard measures for measuring accurate things. Now, this system, international units, is a set of units to maintain uniformity all over the world. So, all over the world, everyone can have the same measurements.
Measurement of a scale with broken ends. You're gonna break them into pieces.
No. Actually, this is not at all the same. Whenever you have a scale with broken ends, instead of throwing it away, I can tell you how to measure the things. Now, first of all, avoid taking measurements from zero mark, because as the end is broken, even if you can't see the zero, but you have the big line which can be representing zero, but avoid taking measurements from zero mark. Then use any other full mark of the scale. Now, if zero is not there, one maybe. If one is also broken, then you can take two. Whatever is a full mark of the scale, you should use any other full mark of the scale. Now, let us take 1.0 centimeter, which is 1 centimeter. Now, subtract the reading first. First, what we have to do, from 1, we have to measure. So, let's measure my pouch again. So if I am measuring my pouch, say that I got 14 centimeter. Okay, I got 14, now I got 14 centimeter as the reading. Now subtract the reading of this mark from the reading at the other end. Now the reading, what? Yeah, so yes, correct. So now the reading here starts from, now the reading at starting mark is 1 centimeter, and at the other end, yeah, like here I am taking 6.5 centimeter. Now what is this? Therefore the length of the object is 6.5 minus 1.0 centimeter, which is 5.5 centimeter. Now you can get how much. So now you can now understand that if you take from 0, how much the length of the pencil or pen or something, whatever object you have. Yes. Now if you are taking from 2 and you got 6.5, then what you are going to do? 6.5 minus 2 centimeters. Then you will get 4.5. Yeah, 4.5 centimeter. Now this 4.5 centimeter is the measurement way of a scale with two broken ends. This is how you measure it. Now, first of all, the most important thing of measurement with scale or whatever, it is that correct positioning of eye is also important for making measurement. Your eye must be exactly above the point where the measurement is about to take, as shown in the figure. Actually, there is no figure right here, but I can show you, because now if my measurement is from this way, I can see the things completely differently. Now, correct measurement I would not get. I would get something else. But if I measure in a perfect manner from the point A to the point B, then I would get the perfect one.
Now, the next one is least count.
Least count.
I didn't know what least count. I did like 10, 9, 8, 7, 6, something like that.
Okay, now let's learn about least count. A scale is marked in centimeters and millimeters. With the scales of this kind, we can measure correctly up to 1 millimeter. That is 1/10 of a centimeter. This is called the least count of a 15 centimeter scale. Did you understand? Once again, let's get that back here. Now a scale is marked with centimeters and millimeters. Now with the scales of this kind, we can measure correctly up to 1 millimeter also, 2 millimeters. That is, so you get 2/10, 1/10 of a centimeters. You can get it like that. Now this is called the least count, least counting of a 15 centimeter scale. You will not understand now. You'll understand it later. It's time. It's time to you to read.
Oh, the next one is measuring the length of a curved line. So you just dump that thing in the paint box.
No. That's completely different. Now we cannot measure the length of a curved line.
Oh, really?
Yeah. How can you measure a curved line directly? No. Just wait. We cannot measure the length of a curved line directly by using a meter scale. Now we can use a thread or a divider to measure the length of a curved line. What?
What is a divider?
If you don't know what's a divider, I'll show you. It's in my pouch.
Oh, we make circles with it.
No, that's a compass. This is a divider. Now I'll tell you how to measure the length of a curved line. When we want to measure the length of a curved line, first of all, what we're going to do is we're going to take a thread and and as the thread also can be curvy, we can just outline it. So first, when you keep it at the point A, the starting point, mark the point as point A. Just highlight it or color it or do something to mark it. Yes. Now next, after taking all the thing at the end point, mark it as point B. Now then take this both points and now measure it with the scale. Then you can understand how to measure the how much is the length of this curved line. And this is how you measure the length of a curved line. Motion. Now in physics, motion is the phenomenon in which an object changes its position over time. Now, motion is mathematically described in terms of displacement, distance, velocity, speed, and time, and all. Now, one can speak of motions of images, shapes, and boundaries, such as, look at this plane, it is in motion. So, something that is moving or changing its position over time is known as, then you can say that that body is in motion. Now you can say me, I'm talking. You can see my hands moving. So my body, like my body is it's changing its position over time. Now that is called as my body is in motion.
Oh, the airplane is in this thing. It's a shape. Right?
Yes. So now the aeroplane, now you can say in the before picture that the aeroplane is in motion.
Yeah.
That's exactly rest, but that's not exactly rest. Now rest, all the stationary objects which are not in motion, that is, do not change their place with time, are said to be at rest. Now you can say the camera which I am recording is not at all moving. It's a stationary object. Now there are two types of stationary. Okay, first of all, stationary is something. First, stationary is our scales, dividers, and all. Another stationary is an object in a still place, something like that, or stationary objects which are not in motion, such as you can say my camera. It's not in motion because it's staying in one position. I'm not moving it somewhere.
Yeah.
Now you can say my body is in motion and my camera is in rest.
Now it's not in rest. When we move it, it's not in rest. I will keep it like this.
Okay, let's go. This is hard for you to read, shall I?
Rectilinear motion, right?
Rectilinear motion.
Rectilinear.
Okay.
Rectilinear motion. That's what I call.
Now, this is the motion where objects move along a straight line. Examples: march past of soldiers, sprinters in race, falling stones, etc. Now you can. Yes. Now you can see these cars. They are moving. These 4 cars are moving in the straight line. Now they are in motion. Now this type of motion, when the objects are moving in a straight line, this type of motion is known as rectilinear motion.
The cars are in patterns. Look, blue, red, blue, red.
Blue. No, it's red, blue, red, blue.
No, let's see that.
Okay, fine. Now let's learn about Exactly. Circular motion is exactly that. When a body moves in a circular path, its motion is known as circular motion. Now, examples of circular motion such as motion of stone tied in thread and whirled, such as you may have played.
It's not world.
So that's what I said. World.
World.
You say no. World.
Oh, you're saying that.
Yeah. So you may have played with when you are like in this kind of age. Yeah, small age. You may have played like tying the stone to a thread and. No, that's not exactly what I want to do. And whirling it like this. Now, this type of motion is called circular motion because the thread and the stone are going in a circular path.
Circular path. So that's called as a circular motion.
Yes, and exactly. Motion of a blade of an electrical fan. The eyes you have to take here very closely look, only the blade of an electrical motion of a blade of an electrical fan is only circular motion. Not a electrical fan's motion is not in circular motion. Next, motion of a second's hand in a clock. You can see a second's hand in a clock, and it moves in a circular motion until and unless the clock is in circle, but still also it moves in a circular motion itself. Yeah. Now, in circular motion, the object remains at the same distance from a fixed point. Yeah. Now we are going to learn about
rotational motion. You're going to rotate it. And if I don't know it's rotational motion, I'll just rotate the wheel.
No, that is no. It's actually the motion of a rigid body which takes place in such a way that all particles move in circle about an axis with a common angular velocity. Also, the rotation of a particle about a fixed point in space. Now, if you didn't understand this, I'm going to just explain it. Because now, if you're seeing a fan, the blades of a fan are going in a circular motion. But what about the fan? The fan is in rotational motion because it has this axle which actually is like an axle, A-X-L-E, which axle? Please.
Okay, you can just
axle, which is on the fan, which actually it makes the fan to rotate, and this acts like an axis, A-X-I-S. It acts like an axis. Now, this type of thing is, now electrical fan is revoluting and even rotating. The electrical fan's blades are the electrical fan's blade are, oh my gosh, the motion of a blade of an electrical fan is circular motion, but the motion of an electrical fan is rotational motion. Now we can even see this hand pulling with force, now producing angular acceleration, and this is the bike tire. You can see the no. This is the axle which helps it to move in a circular path. This is acting like a axis. Now this type of motion is rotational motion. Now let's learn about the next motion. Periodic motion. This is a type of motion where the object repeats its motion after a fixed interval of time. Now, examples: pendulum of a clock, motion of a child on a swing, etc. Now, you can also see the spring in this picture. It actually it bounces and then it comes up and bounces again. Now, after a fixed interval of time, the motion is repeating. The object's motion is again repeating. Now, such type of motion is periodic motion. No, it's not. I don't know. I guess. Combination of motions now. In some situations, the motion of an object may be a combination of two or more of the above mentioned types of motion. Examples: motion of a ball on the ground. Here the ball is rotating about an axis, but the axis itself is moving along a straight line. Thus, the ball executes a rectilinear motion as well as rotational motion. Then we can also see my electrical fan motion. The blades of it is in circular motion, but the electrical fan's motion is in rotational motion. As well as here, the ball is rotating, which is rotational motion, but it's moving in a straight line, which is rectilinear motion. Means this ball is actually a combination of two motions. Now, motion of Earth. Earth executes rotations on its axis and also revolves around the sun.
Yes.
So, rotation on its axis is rotational and revolving around the sun is circular. Now, guys, this is the last one. We're going to learn about SI units. Now, in October 1960, the 12th General Conference on Weight and Measures adopted the International System of Units to maintain uniformity all over the world. This is already what I said. But this system of units is called SI units. That's it. Actually, I explained all of the things before itself. So, in the standard measures. Now, what you have to know is the system of units is called SI units. So, guys, thank you. today. Today we all learned motions and measurements. Today we're not going to do a Kahoot quiz.
Because we learned a lot and we don't have more time to do this.
Yes, we don't have more time to do this.
Yeah.
So guys, that's it for today's video. If you enjoyed this video, please like there, share with your fellow friends, subscribe to, not there, okay? Subscribe to my channel, T for my channel. Subscribe to my channel, T for the chart, T for talent. Bye guys, see you in the next video. Bye.